So, welcome to this talk. I'm kind of surprised to see still a bunch of people to hear about AsyncIO. So, briefly, who I am, I'm Joe. I stopped counting the years I'm working in Python because I'm getting old. So let's just say, long time Python developer. I'm working at Sentry right now, site reliability engineer. I stopped discussing about product. I'm just my relationship is just with machines nowadays. I don't have to deal with people. Really nice. So this talk would be a bit different from what I used to do, because usually it's talking about what I did, which is kind of here's the thing, how you use it, how it works, done, 3 slides, super kind of annoying, right? So this talk is more about the journey that bring me to making an event loop in Rust. I thought it was more interesting. Ladies and gentlemen, welcome to a journey. The journey starts with understanding a few things about AsyncIO, especially given that, how many of you knows what happens when you await something? Okay, a few people. Let's see if you're right, though. So yes, before learning why I did what I did, I think it's interesting to understand what. So, but also given this is a journey, this might sound a bit me ranting a bit about how AsyncIO is implemented. So forgive me for that. And also, another disclaimer, everything I say about event loops is valid only for selectors. So I'm sorry if you're on Windows, you have the proactor event loop. I don't really know how that works. Whatever. So first question: what's an event loop? Who knows what's an event loop? You want to try to answer? No? Nobody? I can give you a hint. That's kind of how an event loop works. So an event loop is something that allows you to register yourself to watch for some events, I/O events. So let's say you want to read or write to a socket, okay? And so you say to the event loop, hey, I want to read, I want to write on this socket, and the event loop is a loop. Right? So you register, and at some point when that socket is ready for what you asked for, it will call you back. It's all about callbacks, okay? So event loops are a simple thing. Simple thing simple doesn't mean easy. It's simple, it's something that doesn't have any complex logic or stuff around, it's very simple. You register for something, and once that thing will be ready, you will call me back. Easy, okay? Sorry, simple. Not necessarily easy. You see, and that's the problem with English. Everybody mix simple and easy. They're not the same thing. And it's also quite simple to understand why we want to use event loops, right? Because we kind of want to do other stuff while we wait for that thing to happen, right? It's quite simple to understand why we want to use something like an event loop, because instead of I don't know, let's say picture a restaurant, okay? You go to a restaurant and you place your order, and in a synchronous world, the waiter would wait for your meal to be cooked before taking another order, which is kind of stupid, right? Hey, if I'm the 10th customer, should I wait for all the customer before me to order and get the meal before even placing the order? Doesn't work, right? It doesn't make any sense. So it's very clear why we want AsyncIO, why we want an event loop, so that we can do It's not about doing more stuff. It's about doing something while we wait for something else to happen, right? It's like if you do your laundry and you make the washing machine, you load the washing machine. And in synchronous code is like if you wait for the washing machine to end, right? Like you just stare at it like forever until it's done, right? Hey, babe, got home. What did you do today? Laundry. Anything else? No, laundry. You know, like 3.5 hours per load. Like, just watch it. Yeah. So in essence, is to move from something like this to something like this. Okay, where we have this magic keyword and something happened in the background, but we don't care. Like, yeah, we do something else in the meantime. Which brings me to the next question, which is, what's a coroutine? Everybody wants to? Anybody? No? What's a coroutine? Oh, you're going too hard. Slow down. Right. Because I had a hint also on this. It's a generator. Because in reality, if you go back in Python 3.4, we had yield from. Yield from, like, it was such a good syntax. Like, it really makes sense. Like, await doesn't mean anything. Yield from, on the other hand, you're generating something, but from something else. Okay? So, yeah. It was all about generators all the time, right? Okay? But yeah, now you know what a coroutine is. Can you do AsyncIO with just a coroutine? No, sadly. You need something else, because again, like you're yielding from something that will happen at some point, so you're kind of yielding from the future, a future, not necessarily the future, but you're yielding from a future. So hey, we need futures, okay? So yeah, and a future, like, it's a really good name, by the way. Like, it really makes sense, right? Like, you're yielding from a future. So let's call them futures. Makes perfectly sense, right? So now we have something else. So now we have like another object that can, so the coroutine like generate that, but then we have something that actually like makes the job, right? Like, hey, when I done cooking the milling, like that's how I tell AsyncIO, hey, I'm done. You can go over, okay? So we now know about future. Is that enough to do AsyncIO? No, not yet. Why? Because an event loop is a simple thing. It doesn't know about generators. It doesn't know about futures. It doesn't, like, it's, again, it's just call stuff. It's a callback thing. So the event loop doesn't know about anything. So we need one last piece, which is control flow, right? Like, you have a generator that you need to iterate over the generator, and if a future returns from that generator, then you have to say, oh, okay, this is a future, right? So at some point it will be done, but you need this control flow to keep going, right? So how do they call that in Python? A task. Why a task? I have no effing idea. Like, that name doesn't make sense. It's not, it's control flow, whatever. Like, they call them tasks. So to actually do AsyncIO, we need tasks. So every time you use any AsyncIO primitive, you kinda, if you read the documentation, yeah, if you pass a coroutine to that, it will be wrapped into a task. So it's everything about tasks. So at the end of the day, you have like the event loop calling these tasks. This is not the real implementation, but gives you an idea on how it works. So you have like the task is control flow. So it will iterate over the coroutine. Hey, I got a future. So now I tell the future, hey, when you're done, call me. Call me back so I can tell the event loop, hey, schedule another iteration. Call me again, okay? It's a loop. It's a never-ending loop. Like event loop.run forever, right? Like, forever. So, congrats, Padme. You finally have a way to write and do async code in Python. And now that we know what, we can start asking ourselves, why? Why re-implementing an event loop? And why not? Like, there's nothing wrong with reinventing the wheel. I spent like the last 10 years of my life reinventing the wheel. Like, reinventing the wheel is good. Like, we kind of live in this strange moment of humanity where, like, it seems, hey, just tab, just use cursor and tab. Don't learn about anything, right? Like, you don't need to know how stuff works, right? Like, just go fast, ship stuff. Don't understand the shit about it, huh? Right? So yeah, like I'm on the other side. I want to know how things works. Like face the same issue that other people face to learn to grow, right? So yeah, why not? But I also have like casus belli, or an excuse for that. Like I opened this on uvloop. You know uvloop? How many of you use uvloop? Oh, a few people. Okay, you should use uvloop. By the way, it's event loop, an alternative event loop implementation made in Python, relying on libuv, and I use it like for everything. So at some point, hey, free-threaded Python came out. Hey, I want to use uvloop. No, I can't. I can't because they don't support it. So I open an issue. That issue is still there. Nobody showed up on that. Okay. So your next question would be, hey, why don't you do the thing yourself on uvloop, like contribute to it? That's why. So it's like 13K lines of Python, and I don't know any Python. Like, it's, I don't know, like, it feels strange, like, to write this strange code. Like, it's Python, but it's not, because it's C, but it's still, like, there's something in the middle. It's very complicated. So yeah, like, let's say that contributing to uvloop, like, requires a lot of knowledge, and also, I don't know if you ever like looked at the libuv documentation, because this is how kind of feels, right? You start opening the libuv documentation, and my God, they do a bunch of stuff, which also means like if you want to use libuv, you really need to learn about it, right? And on the other hand, I know some Rust. Like some is the keyword part here. Like you cannot say, hey, I know Rust. No. You just know some Rust, but I know some Rust, and I already maintain like few packages already made with Rust, you know. The core libraries for my web framework are made with Rust. GeoHasher is just a stupid tiny wrapper around like the GeoHash crate, but hey, it's fast. And I also maintain Granian. You should use Granian. Like if you don't know what it is, like it's a server, it's fast. Sorry, Marcelo, it's faster than Uvicorn. I'm sorry. You should use it. Like try it. I'm gonna see with your eyes. And I also said like, how much hard would it be like to make an event loop? Like again, an event loop is something simple, right? So how hard it can be? Turns out it's not very hard. Like I got the main logic in like a weekend. Like just, you know, trying stuff. It works like in a weekend, got the thing. And again, like it's something simple, like because the even like if you have, yeah, it's a 1,000 line of Rust, but the actual logic, like the actual loop, is like 300 lines. Like that's it. That's an event loop. Everything else is just, you know, APIs so that Python can understand stuff. And also like, yeah, so let's say, let's give you some reasons to use Rust to write an event loop. Like, it's a good idea, it's a bad idea. So let's see some reasons. So first reason, it's literally a loop. Isn't that cool? Hey, I said reasons, not valid reasons. Okay? Okay? Calm down. But yeah, more seriously, You have some really good friends in the Rust ecosystem. You have a few very popular library. PyO3 is amazing, by the way. But yeah, you have like Mio, which should be Metal.io, I think. Like it's the actual name, but it's part of Tokyo, which is like everything doing async stuff in Rust uses Tokyo, right? Like, yeah, they try with some other thing, but at the end of the day, you use Tokyo. So you have like some strong foundations, and also like at the end of the day, like that's it. Like that's the line, one line that listens for events. That's the thing. That's it. The entire I/O is one line. So again, like in Rust, it's very easy to do something like an 11 loop. And also, like, you don't have to make any sacrifices on performance. At least for me, like, you have very few chances of footgun yourself. Like, I mean, like, being a good C developer, like, yeah, I started like with C, first language I ever learned, but like, yeah, I don't know. I'm not Linus, right? Like he knows C. I don't know. The chances to do like to shot yourself, like it's too much. So in Rust, it's so much easier. Like it's very hard to make like big mistakes in Rust, right? And it's also like less weird to me compared to Python, because again, like in Python, you have the Python part, the C part, but the C def, whatever. Like I don't know, just looks weird. But I also want to say it's not Rust versus Python. Like the whole thing is not about, you know, you should start writing Rust, right? It's more about, hey, we have some stuff that like just keep doing what you do. We just want to, you know, move some stuff into some more performance stuff, like keep the syntax, the amazing syntax of Python, the dynamism. It's just about, you know, some stuff. Let's make it faster. Downsides, like it's a bad idea to use Rust to do an event loop in Python. I'd say like the constant maintenance switch between the two languages is kind of painful sometimes. And also, like, you end up having Rust code which is not really Rusty, like, you know, because all the Python stuff cannot have lifetimes or stuff like that. And especially, like, if you try to implement something which is made by the C Python guys. Hey, C Python guys, I love you guys. Like, you do an awesome job. But sometimes, you know, the design decisions of the internals of C Python. And here we go. So an event loop is something simple. But then we started adding layers of abstraction over it, right? Yeah, it's something simple, but we also want to, you know, have like this beautiful abstract interface that has to do a bunch of stuff. Which means if you want to implement an event loop in Python for AsyncIO, you need to do like a bunch of other stuff, right? Like, yeah, the event loop is simple. The TCP stack is not. Definitely not. Like 60% of the lines just for TCP, really? Yeah, that's it. Next question. Does anybody know the difference between a protocol and a transport in AsyncIO? So per documentation, so the official Python documentation states 3 different ways of explaining that to you. And I don't know about you guys, but like when I see something that requires 3 different ways to explain, like it's not a good sign, right? I mean, but who cares? At the end of the day, you need them both. You need them both. Like for every connection, you need a protocol and a transport. Like 2 objects for every connection. So, yeah. Is that cool? I don't know. The event loop is simple. The abstraction layer, could be better. So yeah, at the end of the day, like if you really go deep dive like into AsyncIO, you kind of look like that. So enough of rants and then let's say the actual thing. So first things first, very alpha state. Don't use it in production. Like you can try it, but please don't use it in production because it works if you don't need a bunch of stuff. But it works, okay? And also, like, I don't really love to talk about features. Let's move to numbers, right? Like, you're here for the numbers, right? And that's why you're here. TCP, I mean, like, it took a while to write all that code, you know, all that implementation. But actually, it seems like, yeah, it's faster than both the standard lib, both uvloop. Not so much faster, right? Like you go from 2% to 18% on the standard lib, like 6% on uvloop. Like, yeah, it doesn't change your life, but still, it's I mean, it's performance for free, right? What about HTTP, right? Like, because everybody here is a web developer, right? So on Granian, which is my server, so it's easy. Like I already have like all the benchmarks for this, right? It's not faster than uvloop. Why? Don't really know. So at the end of the day, like, so Granian is a bit particular because it has a lot to do with threads. Like I need to call soon thread safe if you ever saw that line. So there's a lot more to investigate on that. UVcorn, also not faster than the standard lib, not faster than uvloop. But this is macOS. Watch out. Because on Linux, UVcorn, amazing, right? I did something and spent 1 month doing something that is 4x lower than the standard lib. Like, I don't know what's going on with UVcorn on Linux. Man, yeah, we should sit together to see like what's going on. But yeah, anyways, I know like the one guy at the end in the last line have a question. Right? Right? The super Windows. But will it? I don't know, man. I don't know. So what's next? Near future, yeah, I implement all those features you need. Like, understand what's going on with UVcorn, right? Like, but yeah, also like stabilize the Rust interface. So the idea is also like, if you do a Rust library, the idea is like you can use the event loop from Rust instead of Python, which saves you a bit of time. Remote future, a bunch of stuff, maybe Windows. Wanna contribute? Come over, we have cake. No, we don't, but you know. Final thoughts. AsyncIO is quite complex, but it's because of the interfaces we built on top of it. Like the event loop is something simple. Py3, magical. Like there's no other way to describe it. Like it's super cool. And also you can build like performance. Again, is 0.1 faster than the standard lib. Like hey, I'm faster than the whole C Python team that made the standard loop. Okay, and in a weekend. So again, like try Rust with Python because it's very easy to do performance stuff, like even if you don't know a shit about the language. That's it. Thank you.
Thank you, Giovanni. Works? Can you hear me? Thank you very much. Perfectly on time. We still have no questions, but I have a bunch.
Ask questions.
On Slido, remember. Slido.
Or just raise your hand, like just ask.
Or by hand.
So you mentioned that it's faster than the standard lib, in some cases faster than uvloop. Is it maybe possible that it is faster in many cases because it's simpler, because it is smaller? So the reason is not Rust necessarily, but the fact that you just do less things. Except in the HTTP stack, of course. There, I have no idea.
Yeah. So I don't know, because like the benchmarks are like row TCP echo, right? So and I had to like re-implement like the whole TCP protocol and transport stuff like from the standard lib. So on TCP, the amount of things I do is exactly the same, because otherwise like it won't work. Like that's the issue about doing something that should replace the standard library, right? You have to play with the rules that someone else defined, right? So maybe at some point that might be true, but right now, no. I think it's just because I don't know, it's Rust.
Also used Arc everywhere, so
Yeah.
it's not heavily optimized.
I mean, it's Rust, and it's even like not performance Rust, because again, you have to arc everything, like box everything. Yeah.
Other questions?
If you're implementing the event loop from scratch in Rust, which I assume you are, wouldn't it be possible to use a different backend, for example, IO Uring instead of epool, for example?
Yes. Yeah, sorry. I was like a bit speedy on this one, but yes. One idea is also like in the future, like once I have like everything matching the standard lib, the idea is also to experiment with IO ring. Why not? Like, I mean, yeah, it's available only on Linux, only on 5.4, 10, probably better. But yeah, that's an idea, definitely.
Other questions? So I have one. Tell me you have a magic slide, extra slide with the 300 lines of code. I want to see the loop.
You want to see that? I mean, I can show you the loop, probably.
It's just because I like Rust. That's it.
Oh my God, this is super hard. Okay, here it is. But it's, yeah, from here to there. That's the loop.